Hey guys, back to the CNC router project. Got the closed loop steppers installed on Z, Y, and sitting here for the X axis. I just had indicator flags on these for calibration purposes. So now there's twin ball screws and there's gonna be two X motors to keep this gantry, from canting or like getting off at an angle. With the twin ball screws, this will be, in sync side to side. And then we're going to be putting a new spindle in, but that's another time. Got the stepper online, closed loop steppers, and the matching drivers here. With the network Ethernet adapters. These are from Cnc for PC. Arturo over there set me up pretty nice. We've got the UC300 Ethernet controller for the motion controller, and it's all obviously Ethernet cords. Forgive my wiring sins, I'll atone for them at a later date, but we've got this wired up with two power supplies, one 36 volt driving the motor drivers, and then a smaller 24 volt for the UC CNC. And then I'll tie off of one of these and do a step down to 12 volt for some fans and things maybe later. Got an e-stop hooked up here and got our motors hooked up. Now over in the UC CNC software, set it up the way that their manual has. I will say that these drivers from Stepper Online, there's a dip switch here for signal for, let's see here, 5 volts or 24 volts. You can see that here. They come with it set at 24 volts. You want to switch it over to the 5 volt if you're running an Ethernet stepper drive, which we are. So switched all those over, and then we're running this in closed loop mode. Got all the motors wired up, and have a dial indicator on my Z axis here, and you can see that guy's set at 0. And we can go ahead, I've already done a calibration here for the Z axis. UCCNC software has this really nice little calculator. You set it, you can say I want it to move 1 unit, which in this case we're set up for inches, so I'll tell it to move 1 unit. You hit OK, and then it moves supposedly 1 unit, but then you enter the measure value in. I've already run through this and calibrated, so now I'm not going to run through it again, but that's a really nice little tool. And then so we can go to our jog tab here, and I've got my jog settings, and for the Z axis I've got step instead of continuous, and I've got it set at 1 inch step. And then I'm gonna go move my Z axis here. We can go ahead and click this, and you can see that dial indicator is whizzing away as this comes down exactly 1 inch. And we'll get close here. So we started at 0 and we are back at 0, with maybe a half a thousandth of difference, not even a half a thousandth, which is really, really good for a CNC router. For a mill, that's not impressive, but for a router, this is pretty good tolerance. The flex on this chassis, being that this is 3/8 inch steel plate and it's doubled up, there's going to be some flex in here. So we'll be probably doing pretty good to get a thousandth of an inch plus or minus on parts out of this. I'd be happy with even 0.003, which is going to be really fine for anything. Even standard machining tolerances are like usually between 5 and 10, plus or minus 5 or 10 thousandths if you're using a mill. So this router should be on par, with soft materials. Within its build envelope, it should be on par with a full CNC Haas or anything like that. Aluminum and softer, plastics, composites, things like that. And then we won't contaminate the chips on the Haas mills because we have, something that can do, no coolant. It's not going to send like wood or composite chips into a coolant loop and gum up the coolant on the Haas. So that's the purpose of this machine, is to kind of take materials that you don't really want to run in the mill, softer materials that you don't want to contaminate steel or aluminum chips. That being said, making some progress on the enclosure. Got the sides done, but they're off currently. They are polycarbonate windows. You can see one of them sitting there. The other one's on the other side of the room. The next thing is going to be a drawer housing for all the drivers, all the electronics here. So that drawer is going to sit underneath our tabletop. It's going to pull out here, and we'll have all the 4 motor drivers, the UC board, the power supplies. It will have the e-stop on the front of the drawer, I think. And then all the wiring will be nice and tidy, all hidden. And then that drawer, when you pull that drawer out, it's going to have a plexiglass top and a cooling fan, and you'll be able to see all the wiring, and you can lift that. My goal is to have that plexiglass top lift up, and then you can do any maintenance wiring needs, and then set it back down, and then that plexiglass top will be like kind of a work surface. You could lay like a notepad and paper or whatever. And then there'll be a drawer next to it that would pull out, and that one is going to be a full-time work surface, kind of like a keyboard tray. It's going to be actually really similar to this keyboard tray, where it pulls out, but instead it'll have enough room for keyboard, laptop, and mouse. It's going to be a pretty wide tray, almost 3 foot wide, I think, up to that electronics tray. So I'll show you guys another video where we're designing those in CAD, and then show them cut out of sheet metal steel and welded together and put in place. But yeah, there'll be a nice pull-out section here where the laptop, keyboard, mouse will all sit, and then calipers or any whatever you're using to measure your parts. And then I'm thinking that there's going to be a sliding door on the front of this thing. Still haven't buttoned all the details down, but I'm thinking it's going to go upward, and then it'll tilt and then go over the top of the machine and rest there to kind of be out of the way. So that way when you're loading material, you can get the full 36 or 38 inches of material in here. Or if you need to hang material out on the ends a little, you could get it loaded without having issues with the door. This is like a 36 by 22 cut size. Because of we have our limit switches here. We're going to have those on the X. I've got them on the X. You can see the other one here. These are printed on the Bamboo Lab out of a nylon, carbon embedded nylon. And they are really sturdy and really stiff to hold those switches, but they're going to be as well, they're going to be more mounted on the Y-axis as well. And that'll take out some of the soft limits. We had soft limits set up on the non-closed loop motors, but having those switches there is always nice, because you don't want to crash, these plates to crash into the chassis of the machine. It'll just be kind of a nicety, just a creature comfort, but it will reduce some of the travel space. But I think we're still going to have plenty of cutting area with this machine. And then we're on this router, the Z-axis here, we've got about 7 inches vertical as well. So taking this old 6090 router and giving it some upgrades in 2024 to the latest and greatest, the stepper online. These are really popular, and Arturo can get you set up with the UC CNC control board, the software, the drivers, the motors, and power supplies, all of it, pretty much one-stop shop. So I'll link his website as well. Some of the ancillary items, like these motor adapters and the ball screws, came from Amazon. These guys are just a little bit better. They're budget. They're still like, I think, $50 or $60 a piece, but they're going to be worlds better than that single ball screw that ran down the middle. Also with Bill Griggs' suggestion, he's on the Facebook group. I'll link that as well. We decoupled the two sides here. So before there was like some natural tendency for this to like one side wanted to sit further to the right than the other side. And they were kind of fighting each other by cutting this and detaching these pieces from each other. Now the motors aren't fighting. There's no resistance to these relaxing into the same position. So that way one motor is not going to have like tension on it at all times. They're going to be nice and smooth, both these X-axis motors. So that's kind of my update. I will do some more videos once we get more progress done. Thanks.